Alright, number one, it says Bosch had a 70-meter head start. So if we want to draw a head start, let's say this is the starting line for one of them. This will be Bosch's starting point. So he's 70 meters ahead of the other guy. Lewis is the other guy, he's over here. So Bosch is ahead of him and Lewis is behind, which means he's going to be running this direction to catch up. Now it does say how long did it take Lewis to catch up. So that implies that Lewis ran some distance, enough to overtake Bosch and eventually catch up to him, like so. So from the starting point of Bosch, he started here. Oops. He went some unknown distance, but he did cover some distance. So he went d sub b to represent his distance. And Lewis, starting from here to there, also went some unknown distance, and he covered a certain amount of distance. And the head start plus Bosch's distance should equal Lewis's distance. So 70 plus d sub b is equal to d sub l. That's priority one of these problems. Make sure that you draw a picture to represent how the distances relate to one another. Once you've figured that out, then you want to make a rate time distance chart. Our categories here are going to be Bosch and Lewis. Okay. If we take a look at how fast they're running, Lewis is 10 meters per second, and this is in meters per second for rate, which means time is going to be in seconds and distance is going to be in meters. Bosch is traveling 8 meters per second, so not as fast, which is why Lewis is able to overtake him eventually. It doesn't specify anything about time. Anytime you deal with the head start, you imply that the person's here, the other person's there, the starting gun goes off, they take off at the same exact time, he catches them at the same exact time. So even though we don't know either time, we do know the times are equal to one another. Which gives me a total distance traveled by Bosch of 8t meters and Lewis of 10t meters. And once I know this, that's d sub b, and this is d sub l, of which we've already determined how they relate to one another over here. So if I just go ahead and substitute these things in, 70 plus Bosch's distance of 8t is equal to Lewis's distance of 10t. Move the 8t over, and we get 70 is equal to 2t. Divide both sides by 2, I get t is equal to 35. The question says, how long did it take? How long is the question of time? T is the time of both, so that's the correct answer, 35 seconds. Do make sure you put the proper unit. It's not that hard to figure out the unit on these problems, so make sure you do that. Number 2, Robert ran to the redoubt while Wilbur walked to the parapet. Both distances were the same. So even though they're going different places, the distances they're traveling are the same. So all I have to do, I don't have to draw a picture for this one. The fact it says both distances were the same, Robert's distance should equal Wilbur's distance. Okay, that statement right there is sufficient to say the distances are equal. Okay, so then once I've established the distance relationship again, I've got rate, time, and distance as my categories. My categories are going to be Robert and Wilbur. It says Robert's speed was 12 miles per hour and rate's in miles per hour, which means time is in hours and distance is in miles. Wilbur's was 8 miles per hour. What was the time of each? If Wilbur's time was 3 hours more than Robert's, okay, so more than Robert, so they're comparing to Robert, I'm going to let Robert be t. Wilbur's 3 more than t, so t plus 3. And then rate times time equals distance. So 12 times t is 12d for Robert's distance. That's a binomial, so distributive property gets me 8t plus 24 is Wilbur's distance. We've already established that the distances are equal, so I know that Robert's distance of 12t should equal Wilbur's distance of 8t plus 24. Move the 8t over, that gets me 4t is equal to 24. Divide by 4, that gets me t is equal to 6. And the question says, what was the time of each? T represents Robert's time. So if I said Robert, t is equal to 6, then I'm going to write Wilbur, t is equal to 9, because 6 plus 3 is 9. The unit of time is hours in this problem, so again, I don't think it's that hard to establish units. Make sure you get those on there. Number 3, the 80-foot rope was cut into 2 pieces. Here's my 80-foot rope. Cut into 2 pieces, one's longer than the other. So I'm going to put a little slice there and say this is the long piece, this is the short piece. I know the distance from here all the way to here is 80 feet. So one equation I can make without even reading anything beyond this, I know an 80-foot rope is cut into two pieces. The short piece plus the long piece should equal the total length of the rope. The second equation, I'm going to take these words here. One of the pieces was 8 feet longer than twice the length of the other piece. Okay. Obviously, the piece that was longer than twice the other piece was going to be the longer piece. So the longer piece, L, was 8 feet longer than, which we ignored longer than, which is like greater than. So 8 longer than, I'm going to ignore this for right now. Twice the other piece, so that's 2s. This is 8 more than this, so plus 8 on this side. So that's my other equation. L equals 2s plus 8. There's two equations. Now, at this point, looking at the structure of this system of equations, this is set up better for substitution. 2s plus 8 equals L. I put that right there. So my top equation becomes S, which didn't change, plus L, which is changing to 2s plus 8, should equal 80, which doesn't change. So S plus L, this new expression, equals 80 equals 80. Move the 8 to the other side. That gets me 3s on the left is equal to 72 on the right. Divide both sides by 3. I get s equals 24 feet. S is the short piece. It says how long were the two pieces. That's the short piece. If I do 80 minus 24, that makes 56 feet for the longer piece. I could have also put 2 times 24 is 48 plus 8 is 56. Take your pick. But short's 24, long 56, and there you go. Number 4, round to the nearest 10,000th. We see TH, we're talking about decimals. If I count place values, tenths, hundredths, thousandths, 10,000. So that's the 10,000ths place. That's where I'm rounding to. This is the next number. It's not 5 or bigger, so that means that everything before that stays the same. So 109.2535. Be able to count your place value off. So it starts with tenths, hundredths, thousands, 10,000s, 100,000s. Millions, 10 millions, 100 millions, billions, and so on. So just imagine going the other direction, just put TH on the end of everything, starting at tenths. This is the ones, tens, hundreds place, but tenths, hundreds, thousands, and so on. Number 5, find x. Okay, this is a right angle, which makes it a right triangle. Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Hypotenuse is always opposite right angle. So make sure the hypotenuse is all by itself. The other two sides are on the other side. So, or the other two pieces. So x squared plus 64 is equal to 17 squared, which is 289. Subtract 64, that gets me x squared equals 225. So x is equal to plus or minus 15. Since x squared equals that, we take the square root. Since we're trying to find the length of a side, we take the positive square root only. So officially, this has plus or minus 15 as an answer, but we only take the positive square root. Number 6, find x. Same issue. We have a right angle here. The hypotenuse is over here. The legs are x and 7. X squared plus 7 squared is equal to 10 squared. Move the 49 over. We're going to get x squared equals 51. So x equals plus or minus the square root of 51. Again, we're trying to find the length of a side, so we'll take the positive square root only. That's a fine answer. If you want to leave it like that, that's fine. If you type in square root 51 equals 7.14. I would be fine with that answer. I'm also fine with that answer. Take your pick. Go a couple decimal places if you approximate. Number 7, given the points 3, 5, and 7, 8. So I'm going to plot 3, 5, and 7, 8. So here's 0, 0, 1, 2, 3, 1, 2, 3, 4, 5. And then 7, 8. 0, 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay, question A says find the slope of the line that passes through these 2 points. So if I drew a line through these 2 points, like so, they're asking me to find the slope of this line. So basically all I have to do is figure out how to get from here to here or vice versa. I've got to shrink this up a smidge. Maybe. There we go. So, if I go from here to the right height, which is right there, that's 1, 2, 3 spaces up. That's the rise. And if I go across from here across to here, that's 1, 2, 3, 4 spaces to the right. That's the run. Going up is positive, going right is positive, going down is negative, going left is negative. So if I'm going from here to here, I'm going up and right. Those are both positive directions. So for part A, the slope is simply the rise, which is positive 3, over the run, positive 4. There's my slope. Second thing says find the distance between these 2 points. So the second part, all I want to know is how far is it from here to here. They're asking me for the length of this blue segment here. Okay, this is a right angle. This side is 3 units long, that side is 4 units long. So it's another Pythagorean theorem situation. So for part B, d squared, hypotenuse squared, equals side squared plus side squared. 3 squared is 9, 4 squared is 16. That means d squared is equal to 25. So d would equal the square root of 25. Again, plus or minus 5 officially. The positive square root of 5 is the only one that actually makes sense in that situation. So find me both answers for that problem. Number 8, x squared equals 225. That means x equals plus or minus 15. We just did that problem a little bit earlier on the test. This time it's just solve the equation, so both plus and minus are required. Back here, we only needed the positive answer because x represented the length of the side. We wanted only positive. But here, it just says solve, so both answers are legitimate. So make sure you do include the plus or minus in that problem. Number 9, simplify. We do have a division, so we need to make sure this flips over. If I take a look at the 4 pieces, I'll use different colors to represent them. So blue there, red there, we'll go green here, and this magenta color on top. So if I rewrite this problem, the first fraction stays the same, and I do want to factor. 7 times 1, 7 plus 1, so x plus 7 times x plus 1. For the red circle one, 7 times 6, 7 plus 6, so x plus 7, x plus 6. Notice it's multiplication symbol now instead of division. That means that the green goes on top, the purple goes to the bottom. So the one going to the top, common factor is x. If I take x out of these, I get x plus 6 left over. On top, I've got a quadratic trinomial, 3 times 1, 3 plus 1, so x plus 3 times x plus 1. Okay, so the green went to the top, the purple went to the bottom, everything's factored. And now I look at everything that I've got factored, and I'm looking for common factors. If the same thing on top and bottom happens, they cancel. So x plus 7 on top, x plus 7 on bottom, cancel. X plus 6 on bottom, x plus 6 on top, cancel. X plus 1 on top, x plus 1 on bottom, cancel. What's left is x and x plus 3, which don't match. This x matches that x, but this x is attached to a plus 3. So this whole factor doesn't match this whole factor, so I can't reduce anymore. X over x plus 3 is the best final result possible. Number 10, solve. It's a quadratic equation. I see an equal sign, I see an x squared. So job 1 is to get x squared, everything on one side. I want x squared positive, so I'm going to move x squared and 19x over to the left, leaving 34 on the left. I want descending order equals 0. So x squared becomes positive, 19x becomes positive, 34 stays positive because it stayed on the left, equals 0 since nothing is now on the right. Next I'm looking for the breakdown of 34. 2 times 17 makes 34, 2 plus 17 makes 19. So x plus 2 times x plus 17 equals 0. And once I get to this point, factor form equals 0. Either factor 1 equals 0 or factor 2 equals 0. And I simply want to solve each of those equations individually. Move the 2 over and change the sign. Move the 17 over and change the sign. Carry out the addition or subtraction. 0 minus 2 is negative 2. 0 minus 17 is negative 17. And there's my solutions. Number 11. We've got this piece, and this piece. These are being multiplied together, so everything there counts as a single piece. For the purple underlined piece, what I see is a couple pairs of zeros. So there's one pair of zeros, there's a second pair of zeros. Every pair of zeros creates a 10 outside. So 5 is outside already, times 10 makes 50, times another 10 makes 500. Square root of 2 gets left inside. For the next one, there's a couple zeros here. So we got 4 already outside, times 10 makes 40, and that's all the 2 stays inside. On the last one, what I want to do, instead of taking things out of this, I want to put one big radical and then break everything down a little bit more. So looking at this, 6 is 2 times 3, and 12 is 2 times 2 times 3. So looking at this whole thing, there's a pair of 2's, I can take a 2 out. There's a pair of 3's, I can take a 3 out, times a 9 that's already out there, and a 2 stays in. So altogether, what I get out of this first term, again, is just 500 times the square root of 2. I can't make that any prettier than what it is. Minus 40 times the square root of 2. Also can't make that any prettier than what it is. Plus 9 times 2 times 3, which is 54, times the square root of 2, which is the prettiest that can be. And once every term is as simplified as it possibly can be on its own, then we add or subtract if possible. Square root of 2 matches square root of 2 matches square root of 2. So adding them all up is legal. 54 minus 40 is 14, plus 500 is 514 times the square root of 2. So once you figure out that they can add and subtract, just add and subtract the front numbers and put it on the square root of 2 that matches them. Number 12, we're going to multiply 4 times the square root of 3 times this, and 4 times the square root of 3 times this. And again, I'm going to multiply the numbers outside together as normal. So 4 times 2 is 8. But instead of multiplying the 3 and the 12 together, I'm going to break them apart. 3 is prime. 12 is, let's go with that color. 12 is 2 times 2 times 3. For the red one, 4 times negative 5 is negative 20. I'll leave myself a little space here. And then I've got 3, which is 3. And I've got 6, which is 2 times 3. So again, for the numbers outside, 4 and 2 make 8, 4 and negative 5 make negative 20. For the inside numbers, instead of doing 3 times 12 is 36, just to go ahead and break them down again, 3 times 12 is already partially broken down. 3 is prime, 12 is 2 times 2 times 3. 3 is prime, 6 is 2 times 3. Then for each one, find pairs of factors. So a pair of 2's, I can pull a 2 out. A pair of 3's, I can pull a 3 out. Every pair has been accounted for, so that radical is going to disappear. On the red one, a pair of 3's, I can pull a 3 out. A 2 doesn't have a pair, it has to stay in. So altogether, the first term, 3 times 2 is 6 times 8 is 48. Square root of nothing, so the square root disappears. The second term, 3 times 20 is 60, so minus 60, the square root of 2 stays in. This term has the square root of 2, this term doesn't, so subtraction is not legal, so that's as far as I can possibly go. Don't try and subtract those if they aren't allowed to subtract. Number 13, add. What I look for are different types of factors. I've got x's, I've got a 2, and I've got x plus 2. Each of those represents a different factor type, and what I'm looking at is each different factor type and its highest power. So looking at x, my choices are x and x squared. The highest power is x squared. 2 is just to the first power. X plus 2 is just to the first power. So when creating a common denominator, 2x squared times x plus 2. If you have more than one object, put it in parentheses. That's what I want every denominator to be. So I got fraction 1 is going to have that denominator. Fraction 2 is going to have that denominator. And fraction 3 is going to have that denominator. Okay. Notice that fraction 1 minus fraction 2 minus fraction 3. So make sure the structure of the problem stays the same in your work. The initial fraction 1 is 3 over x squared, so I'm going to put 3 on top. Fraction 2, x plus 5 on top. Fraction 3, 4x on top. So what I have to do then for each fraction is see how it changed. So what it is before and what it is now, how it changed, and then change the top accordingly. So This first fraction, x squared, is already there. The 2 and the x plus 2 are new, so times 2 times x plus 2. Second fraction, 2x is already there, so there's an extra x, and there's an extra x plus 2. And then the last one, x plus 2 is already there, so 2x squared is new, so times 2x squared. Okay. The only challenging part to this whole simplification at this point is this middle thing here. I would recommend doing all this stuff somewhere else and bringing it down here. So if I did x plus 5 times x plus 2, that's going to be x squared plus 2x plus 5x plus 10. That's this much of it. That's being multiplied by x, so times x is going to make x cubed plus 7x squared plus 10x. So that's what I recommend. Simplify that, then bring it down. And simplify this and bring it down. So this is 6 being multiplied through this. 6 times x is 6x. 6 times 2 is plus 12. All that's over 2x squared times x plus 2. The second fraction, all this top stuff, this times this is that, times x is that. So x cubed plus 7x squared plus 10x. All over 2x squared times x plus 2. And this is just one thing times one thing. So 4 times 2 is 8. X times x is x cubed. All over 2x squared times x plus 2. Now, minuses. This minus is going to minus not just the first object, but the second object and also the last object. This minus is only subtracting that because there's only one object. So be careful, minus signs distribute all the way through. There's no minus sign in front of this one, so that's just 6x plus 12. So if I go ahead and combine like terms as I simplify all this stuff out, if I focus on the x cubes first, that's not x cubed, that's not x cubed. I've got negative x cubed, x squared x, don't count, minus 8x cubed. So minus x cubed minus 8x cubed makes minus 9x cubed. Then if I look for x squareds, x the first constant, already dealt with the x cubed, minus 7x squared, and that's it. Looking at the x's, 6x minus 10x. Constants, plus 12. All that goes over the common denominator, 2x squared times x plus 2, and that is the answer to the problem. A little bit more challenging than some of the ones we've seen, so that's when you want to practice a little bit. Again, work this whole thing out to get an expression, and then make sure the minus distributes to the expression. That's the most common mistake people have on this problem. Number 14, solve. Okay, once again, I got a minus in front of a fraction, so be careful with this. The common denominator of all the fractions is 15, so times 15 will get rid of the fractions. 15 divided by 3 is 5 times x is 5x. 15 divided by 5 is 3, it's actually negative 3 times the top x plus 3. And 15 divided by 3 is 5 times 1 is 5. I wrote it this way so when I distribute I can more clearly see what's going on here. 5x is 5x, minus 3 times x is minus 3x. Minus 3 times plus 3 is minus 9 equals 5. Okay, so that minus sign there is one that's frequently missed, be careful with that. Minus 9 moves over as a plus 9. 5x minus 3x is 2x. 5 plus 9 is 14. Divide by 2, we get x equals 7. And number 15, find the surface area. Directions. So surface area is area base, perimeter base, and height first. Once we establish those three values, then we apply the formula. So, looking at this base, which is this is the base of the right prism, 14 feet high. So, 14 feet high, height is 14 feet. Everything else, B and P, comes from this two-dimensional figure. Looking at B, I've got rectangles all over the place, so it's however you decide to break it apart. I'm going to put a dotted line right here and a dotted line right here to break it into 3 rectangles. First rectangle is 3 by 8. Make sure you use the entire length, entire width. 8 times 3 is 24. The middle rectangle is, if that's 6 and this is 8, this little piece here is 2. If that's 3 and 5, which is 8, and that whole thing is 12, this little piece here is 4. 2 times 4 is 8. And then finally this piece is 5 for a width and 8 for a height, so 8 times 5 is 40. Area 1 plus area 2 is going to be 32, plus area 3 is going to be 72 square feet. And finally, perimeter is just the sum of all the outside edges. This is 12, this is 8, this is 3, this is 6, this is 4, this is 5, this is 8, this is an outside. So only the outside edges count. Oh, and there's another 6 right here that I almost forgot about. Be careful. All the edges are accounted for. So know it, 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 know it. Everything's known. Add them all up. So I'm going to start here and go around this way. 8 plus 3 is 11, plus 6 is 17, 21, 27, 32, 40, 52. Once we know both all the area, perimeter, and height of everything, then the formula for surface area is 2b plus pH. So once we've established these three numbers, 2 times b plus p times h, 2 times 72 is 144, 52 times 14 is a little bit harder, 728. If I add that to 144, I get 872 square feet. Just to verify my math, 872. So there you go. It'll be a similar looking figure on your test. Again, some missing sides, so you have to find the missing sides based on rectangular properties. Find the area, find the perimeter. Height will be given in the words. Apply the formula correctly to get the surface area.